Hello and welcome to the short introduction on the Chrono Super Serializer package for Unity. This package allows you to very easily introduce a time rewinding mechanic to a Unity game. What I have right here is a game for which I originally made the package. It's a relatively simple game featuring side-scrolling, simple combat and platforming. This game does, however, acquire a lot of additional depth through the time rewinding mechanic. As you can see, the time rewinding works accurately, smoothly and in high detail. I can rewind time slowly, quickly, backwards and forwards. I can even rewind time back to visit previous levels. The plugin works essentially just by saving and loading game states very quickly, hence why it's called a Super Serializer. The loading is so efficient that you can store and reload hundreds of hours worth of gameplay without using unwieldy amounts of memory. The specifics depend on the game and the settings, which can be adapted to fit your needs. Links will be in the description if you're interested in this game and if you want to try it out for yourself. Moving on, I will show you how you can implement this package in your own game. For the sake of this tutorial, I have made a simple version of the previous game, which just the same allows you to control a character in 2D space and move from level to level. I also have a few additional props that I will get to later. To get started with implementing the Chrono plugin, I will first add a new game object, which I will call timeline, and add a Chrono timeline script to it. Do not worry about these variables just yet, I will only fill in a folder where we can save our data. To enable the timeline, we need to do a little bit of custom scripting. This part is a bit complicated since I wanted to make sure the timeline could be used in a flexible way. Bear with me though and we'll get through it quickly. First of all, we will take a look at this timeline start function, which is trying to enable the timeline. First, we can check if the timeline is already enabled and if so, return immediately. Otherwise, we will fetch this menu scene, which in this case does not exist, so we can just fill in a placeholder, and the scene in which we want to start the game. So we will call the initialize function, which immediately tries to look for existing data and will return true if there is pre-existing data. If so, we can simply continue. Otherwise, we will do a fresh start in the current scene. If we do a fresh start, the timeline will not immediately be enabled, so we have to do this manually. Next up is the update function, which is handing control over the time rewinding to our player. You can see here that it's simply fetching a little bit of input, using the left control key to toggle on or off the manipulation, the left and right keys to go forwards or backwards faster, and the space key to pause time. If we are manipulating, we have the option to stop manipulating, or we can change the time factor at which we're manipulating forwards or backwards. If we want to pause the game, we can simply pass that to the timeline as well. So, if the timeline is not manipulating, so we are just playing normally, and we hit the toggle key, we can start manipulating. Fairly simple, but this can be a lot more complicated if you want it to be that way. Finally, we have this little update function. And this is only there to provide a little bit of information to the game. First of all, we have an overlay that we will turn active whenever the timeline is actually manipulating. And we can also set a little bit of text and give a little bit of information about our current time and the length of the current scene. Coming back to the Unity editor, we can now try out the game. But we will quickly notice it is not yet working. If we rewind back to 0, we hit a hidden scene transition, which is why the scene suddenly resets. The problem here is that we haven't told the timeline which objects it should target for serialization. We can do this by simply adding a memento marker component and have it target whatever components need to be rewound. Say for example that we want to target the position of our character. We will go to the character, add a memento marker, and then target the transform. Now, if we play the game again, we will see a few errors popping up in the console. This is because since the structure of mementos in this scene has changed, the old save files are no longer valid and the timeline doesn't really know what to do with them. The timeline will automatically delete invalid files, so all we need to do is to stop and play again. We can again jump around a little bit, and now the position is properly being rewound. You will notice, however, that all the other features in the scene, such as the animation, the particle effect, and the rigid body, are not yet being affected. You will solve this by adding more memento markers. First of all, we'll go to this physics cube and target the rigid body. We can go to the patroller, which has the particle system, and then target the particles. Then we'll also go to the character, add yet another memento marker, and target the animator. Again, we should hit some errors since the scene has again changed. And we can now play again. And now we should see most of the things rewinding as expected. You will notice that there is still one part that is not rewinding properly, which is the position of the particle system. The problem here is that this particle system is being controlled by a custom script. We can of course add just another memento marker and target the script. But when we do this, we will run into a few new errors. This is because the timeline doesn't yet know how to handle this custom component, so we need to tell it how to do that. Moving on now, we're taking a look at our custom script for which we want to implement a Memento clause. The Memento clause will define how it is saved and loaded. In this case, our example script really only depends on a single floating point value which we need to save. To do this, we can go to the bottom of the script and implement a Memento clause. The Memento clause should always have the same name as the class that it is saving, with the word memento attached to the end. It should always implement component memento and always be marked as serializable. Any variables that we want to save should be defined here, and then we only need to implement 3 methods. The first method is called whenever a frame is being saved. In this case, we are receiving a Chrono example script, which is the component that we are trying to save. And we simply need to extract all the values we want to save and assign them to our own class. So in this case, we are receiving a Chrono example script with our floating point value x. And we are taking this and assigning it to our memento. Apply is also fairly simple. It is used whenever we are loading a specific frame. In this case, we will receive a component, which is always a Chrono example script in this case, so we can simply cast it and then do the opposite. We will take our saved value and assign it to the component. Next up is a lerp function, which is used to load a state in between 2 saved frames. In this case, we do not only receive our target component, we also receive the next memento and a factor which is telling us how far between the two mementos we are currently. In this case, we can again do a few casts, since our component will always be our chrono example script, and our second memento will always be the same class as this memento. Next up, we take our values right here and the value of the memento that we are receiving, and we interpolate them using this factor. This gives us a value that's in between the two frames, and all we need to do is fill that in the target. In this case, the position is being set in the update function of our chrono example script. So in order to make sure that it's always in the right position, we will call an additional update at the end of the slurping function. Coming back to the Unity editor, I will quickly implement our markers for our second scene. This scene really only holds our character, so we will just add a new memento marker, target transform, then go to the animator and target that as well. Save this, come back, and now everything should be working. We can head over to the second level. And everything seems to be working properly. You can see right here the movement is a little bit strange. This is because the precision of our timeline has been set to a fairly low setting, but we can fix that later. Now that you know how to use the plugin, I can go over some additional info that may be important to your use cases. First of all, you must remember that you cannot spawn or delete any game objects that have memento markers attached to them. So, say you want to have a rocket fire and travel a path that can be rewound. In this case, the rocket actually needs to be present in the scene right from the start. You can disable it and enable it when the rocket fires to achieve the desired effect. If you need to do this multiple times, it's also good to reuse the same rocket, since this saves a little bit of memory. Another thing you may have noticed is that each memento marker has this reset on level revisit flag. This is pretty self-explanatory. Whenever you revisit a level in the normal way without rewinding time, all the objects will be loaded to their last state that they were in the last time you visited the level. If you do not want this to happen, say you want to control the position of the character manually, you can enable this flag. The timeline script itself also has a few variables you may find interesting. If your game already involves some sort of changing timescale, you might find that the chrono timeline messes this up. The play timescale is provided so you can avoid such conflicts. You simply have to set this variable instead of directly changing the time.timescale variable. The minimum time interval is the smallest time that can be between two saved frames. If you make this variable very high, you will save a little bit of memory, but the rewinding will become a little bit more ugly. If you set this variable very low, if I set it to 0 for example, you will be saving every frame, which costs extra memory but will make the timeline really smooth. The other three variables, intermediate, maximum, and recent limit, are used to progressively thin out the number of frames in order to save long-term memory. So, in the same fashion, if you want to have maximum smoothness, you can set these to 0. If you want to save a lot of memory, you can set these variables very high. With that, you should be all set to get started yourself. Good luck with your projects, and goodbye.